Now we're doing the review for 4-2 or 4.2, and the question is, how long will it take for the value of an account to be $1,200 if they start with $725 and the interest rate is 9% compounded continuously? So R equals 0.09. P sub aught is $725 and P is $1,200. And here's our equation, so we'll replace P with 1,200, and I'll leave the dollar signs off, and 725 e to the 0.09 t. Now, first thing, we'll divide both sides by 725, and that equals e to the 0.09 t. Well, this reduces, and 25 goes into each of those, and into 1,248 times, into 725 29 times. And here we have our exponent. Now we'll take the natural log of both sides, so we get ln of 48 over 29. Make sure you put parentheses around that when you enter it into your calculator. And by the law of exponents, we can bring the exponent down into coefficient position, and you know that ln of e equals 1. So we have ln of e times this, but that's just 1 times that. So solving for t, we'll divide both sides by 0.09, and we get ln of 48 over 29, need parentheses there, divided by 0.09. And when we enter that into the calculator, we get approximately 5.6 years. And we're done with that one. Now we're doing question 2, and it says radioactive carbon-14 has a continuous compound rate of negative 0.124. Estimate the age of a skull uncovered at an archaeological site if 9% of the original amount of carbon-14 is still present. Well, here's our equation. So 9% of the original amount, in other words 0.09 times the original amount P sub aught, equals the original amount P sub aught e to the, and the rate is negative 0.000124 t. Now, if we divide both sides by P sub aught, the P sub aughts divide out, and we're left with 0.09 equals e to the negative 0.000124 t. Now let's take the natural log of both sides. So we get ln of 0.09 equals, and now we know by the law of logs, in fact let's do it the long way, ln of e to the negative 0.000124 t. So ln of 0.09, by the law of logs, we know we can take the exponent, put it in coefficient position, 124 t, ln of e, but ln of e equals 1. So therefore, this is just 1 times this, so we get ln of 0.09 equals negative 0.000124 t. Now let's divide both sides by the coefficient on t. So we get t equals ln of 0.09 divided by, and that's going to be negative, because we're dividing by a negative, 0, so I'll put the negative sign right there, 0.000124. And so when you run that through your calculator, I wind up with 19,424.5 years, and that's approximately. So that took care of number 2. Well, now for number 3, we just have to take the derivative of this, so f prime of x equals, and the derivative of e to the x is e to the x, so we just get 3e to the x. Plus, now we're going to have to use the power rule, so we bring the 3 down, multiply it times 15, and we get 45. Then reduce that exponent by 1, and we're done. There it is. Let's do 4 also. So here we have y equals 2 to the x minus e to the 15th. Now keep in mind, e to the 15th is just some constant, very big number, but it's just a constant. So when we take the derivative of that, dy dx, that's going to equal 2 to the x ln of 2, check that rule out, and that's it, because the derivative of this thing, it's just a constant of 0, so we're done with that also.